Welcome to the Beowulf Bash scripting class. In this section, we'll take a look at how the shell handles input and output for processes and how we can redirect these. When we obtain a shell on a Linux system like Beowulf, the shell opens 3 communication channels or streams for processes to interact with. These are set up as connections to the user's hardware devices. The 3 channels are standard input, which listens to the user's keyboard and is abbreviated as standard in. Standard output that shows up on the user's screen and is called standard out. And standard error, which is specific to error messages and is also directed to the user's screen. Let's see what these look like in practice. Here we are logged into Beowulf on the bash shell prompt. To understand the 3 standard channels, we'll use the cat command, which is short for concatenate. Let's see its manual. We learn here that this command prints the contents of files or the standard input to standard output. Let's try that. To exit the manual, hit Q. In my home directory, I have a file called phrase1.txt. We can use cat to print it to our standard output. Essentially, cat printed the contents of phrase.txt to my screen, which is standard out. Cat also prints standard input, which is the input from my keyboard, to standard output. So if I just enter cat without a file, the command waits for my input. Let's do that. I hit enter and it returns the input to the standard output. Cat will keep listening to standard input until I send an end of file signal with Ctrl D. So that demonstrates standard output and standard input. Standard error is similar to standard out but shows up when a process encounters an error and sends a message telling us what went wrong. This again goes to our screen. So for example, if I cat a file that doesn't exist, we see the error message from cat that this file doesn't exist. Now we know what these channels or streams look like. This schematic shows us how a process started by a command expects the shell to set up the 3 channels or streams. These streams live as always open device files, which all exist in /dev. Dev being short for device. For example, standard in listens to the file /dev/standardin. The Linux operating system keeps track of these type of device files using labels or handles called file descriptors. Let's go deeper into file descriptors. These are single-digit integers between 0 and 9. The first 3 are reserved for the standard input, output, and error respectively. Standard in is 0, standard out 1, and standard error 2. As I've mentioned before, these are all channeled to the user's hardware. This is done through the terminal application we have open. It turns out the open terminal is also identified using a device file. On a local machine, this usually is /dev/tty. But when you are logged into a multi-user system like Beowulf, the terminal device file is located somewhere else. By default, all 3 standard channels, standard in, standard out, and standard error, point to the terminal identifier. Let's go back to the terminal to confirm this. We'll start with first identifying our terminal. The command tty can help us do that. If you've seen our section on processes, you'll remember that we can also get this information from the ps command under the tty field. Now let's look at the standard channels. I'll start with standard in. We'll use ls with the L flag to examine the device file for standard in. The output of ls tells us that this device file is itself a link to a file located at /proc/self/fd/0. The fd in this path stands for file descriptor, and if you remember, the file descriptor for standard in is 0, which is where this file path ends. Now let's look at the second path. This output shows us that the standard in file descriptor links to the terminal we identified before with tty, which shows us how the standard in channel is listening to the terminal, which is in turn taking input from our keyboard. We can do the same with standard out or standard error. For example, you'll notice the file descriptor is 1 for standard out. Let's follow that link further. Which in turn points to our terminal. So now we see how the standard channels, input, output, and error, are all pointing to our terminal. Now, instead of device files, these channels can also be redirected to or from user-specified files. Let's start with learning how to redirect standard out, since that is often most useful. There are many ways to do this in Bash syntax, but there are two common ones. The simplest way is to add the greater than symbol at the end of a command and then add the path of the file we want to redirect standard output to. The second way is more explicit and shows us what the instructions really are. We tell the shell to redirect file descriptor 1, which is standard out, to a file. This table shows where the file descriptors point to when redirecting standard out. Standard in and standard error are still pointing to the terminal. Let's see how to redirect standard error. In this case, we tell the shell to redirect the file descriptor 2 to a file. Looking back at our redirection table, now standard in and standard out point to the terminal, only standard error is redirected to a file. We can redirect two channels at the same time. Let's do that with the standard out and error. One way to do that in Bash is with ampersand and the greater than symbols put together without a space in between. In this case, the redirection table shows us that only standard input is pointing to the terminal, while the other two channels point to the same file. Another way to do the same is to first point standard out to a file and then instruct the shell to point standard error to standard out. In other words, file descriptor 2 is pointing to wherever file descriptor 1 is. The shell reads redirection statements from left to right, so the order is important. Keeping that in mind, these two redirection statements are not the same. Here, the first instruction redirects standard error to standard out, which by default is pointing to the terminal, and then we instruct the shell to redirect standard output to a file. This sets up a redirection that we probably didn't intend, as now standard error is going where standard out was originally pointing to, the terminal, and now standard out is redirected to a file. We can also redirect standard out and standard error of a command to different files, as seen in this statement. Now let's see how to redirect standard input. Here we use the less than symbol. Before the command is executed, Bash will first attempt to open the file and only proceed with the command if that is successful. We can of course redirect both standard in and standard out simultaneously, or redirect all three at the same time. Finally, before we get to the demo, I just want to point out a few things. First, we can set up standard output or error redirection to append to a file using two greater than symbols together. This means the existing contents of the file will not be overwritten. Rather, the standard output or error will be added at the bottom of the file. This can come in handy if you want to accumulate the output of multiple commands in one file. Relatedly, it is very important to be careful with redirection. It is quite easy to overwrite files or append to files that you don't intend to change. Finally, these redirection statements may be Bash specific, so please make sure you're using Bash instead of other shells before setting up the redirection based on the examples we've seen so far. Now let's see how all these redirection statements look like on the command line interface. We're back on our Bash shell on Beowulf. Let's clear the screen before we begin and confirm that we're indeed using the Bash shell. You might remember our phase1.txt file. Let's see its contents with the cat command, which prints the file to standard out. Now I want to add a new line to that file. There are many ways to do that, but let's see how we can use redirection. We'll use the echo command. Quick recap, echo is used to display a line of text to standard out. But as we know, we can redirect the output. So let's give echo the same line and redirect it to a file phrase2.txt. I'm going to use a Bash shortcut to bring back the last command I ran with the up arrow. Now I'll add the redirection. Let's confirm the contents of this new file, cat phrase2.txt. Now I'll combine the two files using cat again. Now we can redirect the output to a new file. Again, use the up arrow to bring the previous command back to the prompt and add the redirection. Just to confirm, let's use the more explicit standard out redirection. And we'll confirm again, ls cat complete phrase.txt. Good. Now we know how to redirect standard output. But instead of creating two phrase files and concatenating them with cat into a third file, I could have simply used appended redirection. Let's see what that looks like with the echo command. We'll add a third line to complete phrase.txt. Echo. And now I'll confirm that the previous contents of the file were not overwritten, while the last line was added. Okay, moving on to standard error. Let's try this example. Text. I get an error message from cat that the file phrase3.txt does not exist, which is indeed the case. Still, the output of the existing files is successfully redirected to the new file. If I don't want to see that error message, I can redirect that to a file as follows. And simply go up and redirect error. Now we don't see the error message because it got redirected. We did see the output though, so let's fix that. I'll use the up arrow again and edit the command line. Let's check what we have now. And cat error.txt. Now let's move on to standard input. We'll keep using cat because it can also work with standard input. Note that this really is a bit redundant because cat by default takes as arguments the files to read, but I'm mostly using this for the demonstration. Let's try another standard in redirection. That gives us an error saying phrase3.txt does not exist. But note that this is an error from bash instead of cat. Cat phrase3.txt gives us the same error, but the message originates from cat instead of bash. And this is because during input redirection, the bash shell checks if the input file actually exists before running the command. Let's combine input redirection with error redirection. This will append to the error.txt file. That doesn't work. This shows that even before the error redirection is set up, bash stops the execution of the command because the file or standard input does not exist. As a result, we cannot capture the error message in the error.txt file. I hope with these examples you were able to get an understanding of how redirection works. To summarize, in this section of the Beowulf Bash scripting class, we went over the three channels: standard input, standard output, and standard error. We saw how they are set up to communicate with our devices, the keyboard and the screen. Then I touched on file descriptors specifically in relation to these standard channels. And finally, we saw how to redirect these to and from files. If you have any questions or comments, feel free to email us at staff.hpc.nih.gov. And thanks for watching.